Good evening, everyone. Welcome to Kubernetes Sri Lanka Meetup. Today we have Afkham Azeez, who is a Vice President and Deputy CTO at WSO2. Today he's going to talk about SREs and Kubernetes. So, Azeez, screen is yours.
Okay, thanks, Chamod, and welcome everybody. Good evening, good morning, good afternoon, wherever you are. Today I will be talking about SRE and Kubernetes, and mainly I will talk about some concepts around SRE, and actually talk mostly try to discuss. The experience or the work we have been doing related to SRE at WSO2. And then we will open up for questions. One second, still figuring out the software.
No, so far we don't have any questions.
No. I just wanted to. So like Chamod mentioned, I am Afkham Azeez, VP and Deputy CTO Cloud at WSO2. So my background is mainly in software engineering. So I have been a developer almost throughout my entire life, and that's what I enjoy. But since the past 2.5 years, I've been working with SRE, Kubernetes, and it's a new experience for me. Leading a team of talented people at WSO2 in this area, and we started the SRE practice. I will try to relate how you can transition from developer role, or how development or development experience or those methodologies are a very good expertise to have when it comes to this area in SRE. So you have my contact details on LinkedIn, and you can follow me on Twitter. Lots of hobbies, and I like to spend my spare time off-roading in the jungles, camping, and so on. Right, so to set the stage, let's look at what happened in 2022, right? 2020, right? COVID hit. It was a game changer, isn't it? What happened was, many companies started realizing that, in order for them to survive, they have to build digital experiences, right? It's not an afterthought or a nice to have thing anymore. So if you want to survive in the new normal, you need to think differently. So there's a major paradigm shift, and major changes are happening on how software is designed and built. And businesses have realized that they have to build digital experiences. They can't simply buy, right? Each business is unique. They have to build these digital experiences which are sort of unique, or which bring out their value proposition. The main challenge is, many companies like LinkedIn, Airbnb, these big logos here, they have been doing that for years. But it's not just that these companies, even mom and pop stores, they need to have a digital front in this new era, right? With online, everything being online, and life going on, and the thing is, like, even after COVID, we have learned quite a lot of things during this COVID experience, right? This is going to be how businesses are going to operate. So it has opened up lots of avenues, and it has given new insights into how businesses need to operate in this new era. So the challenge is building digitally driven businesses takes time, and it requires a significant engineering effort, right? So we'll come into these details later, but these are some of the points to keep in mind. So now, welcome to the era of cloud native software engineering, right? In the good old days, when you want to build software and you want to run it, you would start about you would start thinking about how you are going to host it, right? Either you have your own data center, or you have a shared rack space or something like that, and you run your own systems. But now the default way, or the most natural, or the most cost-effective way is to run on the cloud, right? Because cloud provides you most of the advantages. So the thing is, like, in this new era of cloud native software engineering, like, I like to simplify this as building for the clouds. If somebody asks me what cloud native software engineering is, in very simple terms, I would say building for the cloud, on the cloud. So that means your teams they have their dev environment on the cloud, and they, from day one, they have everything set up. They have the machinery running there. They start developing the software, right? So that's the way to do things in the new era. Like, some of you guys might remember, product engineering companies used to build their products, ship it, and then it's a separate team that sort of takes it and is completely responsible for running it on the cloud. So with this new approach, actually that line is blurred. So the teams are actually developing on the cloud, and once it's ready, it gets promoted, right, from dev to stage to testing, from dev, and finally to production, right? And another interesting thing is, like, APIs have now replaced libraries. So you used to, if you want some functionality, you used to look for reusable libraries, right? Either you build it yourself, or you look for reusable libraries. But now you look for APIs. So you don't build everything yourself. APIs are the new libraries. You integrate with APIs, and it can be business APIs, system APIs. So if you're running on some cloud provider like Azure or AWS, you would use their storage APIs, and so on, right? So analytics APIs, you name it, right? You don't build everything yourselves from scratch. You rely on platform APIs as well as business APIs. So in this cloud native way of engineering software, Kubernetes and containers are major game changers. So now anybody can write their code, package it as containers, and you can run it on Kubernetes. And it sounds very simple, because you have managed Kubernetes solutions out there, right? You have the solutions from Amazon, Azure, Google, and so on. So it's very simple, isn't it? Right? You just write the code, you package them as containers, and then you run it on manage Kubernetes. Or so you thought, right? So all that sounds really good. It sounds very powerful. But along with all the power comes a lot of complexity. So if you just get started with the container world and Kubernetes and stuff like that, you feel, wow, this is so great. You can just write your code, package it, write a few Kubernetes manifests, and simply run it. And especially if it's managed Kubernetes, everything will run, and life and everybody will live happily ever after. But the reality is not so simple. So this is a great article. I have shared the link on this slide. On the title of the article is why, 2 reasons why Kubernetes is so complex. Right. So that article has a very interesting perspective. So like this article is in line with what I have been thinking over the past couple of years as well. So if you sort of look at the crux of it, Kubernetes is a cluster operating system as well as a collection of control loops, right? So if you think about it, the you guys who know Kubernetes, right? If you look at an operating system, you have a kernel, right? And then the kernel has certain system functions. You have system calls, right? So you can make system calls to do certain things, and so on. So if you look at the if you look at a core aspect of Kubernetes, it behaves in a very simple manner, in a very similar manner. Sorry. What happens is, you have this programming layer. So on the operating systems also provide programming APIs. So you define, you use those APIs, which will result in system calls and so on. And then you write your workloads, your applications that run on top of operating systems, right? And then the operating system takes care of all the underlying complexities. It provides a nice abstraction. So in a way, Kubernetes provides this in a distributed manner, like storage APIs and file mounting, all that stuff is abstracted. So these are like the system APIs operating systems provide you. So in effect, it is a cluster operating system. In addition, it is a collection of control loops. So if you look at anything you do in Kubernetes, so let's take an example, right? You deploy a pod. So immediately, that command would return, and then there is this continuous feedback to see whether the required state has been reached. So you write the manifest, and then you basically, what you're doing is actually stating some desired states, right? So there is a continuous feedback loop that checks whether that is successful. So once that is successful, your pod will be running, right? In addition, there's continuous feedback even after the pod starts running, right? So you have the health checks and so on, which continuously feedback, provide feedback, and then your state is reflected there. So again, like what I'm trying to come to is, all of these things can be thought of as programs, right? Programming a distributed operating system plus programming what do you call the control loops. So we can actually we can apply programming paradigms and concepts to this direct, right? So this is why, like I said, I come from a software engineering background. It makes it very easy for developers to adapt to this kind of thinking, because it's very natural, and it's very similar to programming. So like here actually, when it comes to writing, like when you're specifying a Kubernetes deployment or cron job or whatever, you are actually declaratively stating what state it should be, right? It's sort of a declarative programming paradigm. So yeah, this is a good article that I would recommend you guys to go through, a short one. It's a bit it's thought provoking. So yeah, coming to now code, right? So so infrastructure as code, all of you are familiar with this. How do you represent infrastructure and system concepts as code? So that is infrastructure as code. So the definition is the process of managing, provisioning computer data centers through machine readable files rather than physical hardware configuration or interactive configuration tools. The good thing, so there are like so many great things about this concept, right? One thing is the repeatability. So let's say you have now written a script which spawns some machines for you, right? It can be VMs or whatever, right? So this is now repeatable. So once you have written that, it's repeatable. You can run that script again and again, and it will provision all of this hardware and storage and whatever, right, for you, right? So the other thing is now you can now accept, you can apply concepts that are used by software developers, like you can tag these, you can version these scripts, you can branch it, and you can put it into a code repo. People can fork that code repo, they can send pull requests. It opens up quite a large vast area of things that can be done when you represent infrastructure as code. So everything is code in this world. So like if you want to create clusters, you write code. Creating workloads, it's code. Like security configuration as code. Everything this is a very simplified but powerful way of looking at systems. So now how does SRE come into this picture, right? So let's look at what SRE is. So now we are like we spoke about infrastructure as code and software engineering and so on. So SRE is an approach taken to solve IT operations challenges using software engineering principles, right? So coming from a software engineering side rather than a systems engineering side. So this is why it's very natural for developers to take on SRE roles. So SREs use software tools to manage systems, diagnose problems, and automate tasks, right? Like I mentioned, code is stored in code repositories, and software engineering practices such as continuous integration, continuous deployment, static validation, static analysis, code reviews, all those things are done on this infrastructure code. So another very important point is this point number 3. A key role of an SRE is to find the right balance between releasing new features and ensuring that they are reliable. So it's a balancing act, right? So they need to ensure that the system is reliable, because at the end of the day, there are users and customers who are using these systems. So these systems have to be reliable. In addition, development teams, they are keen on releasing new features as soon as possible, right? So SREs play a role in balancing both of these. So you can't compromise reliability as well as if you want to keep your system 100% reliable, you mustn't touch it. Once it's working, you just leave it as it is. But then your system is going to get stagnant, and you will start losing business after some time when innovation dies. So you need to be releasing new features, but you need to ensure that those are done in a manner that doesn't compromise or make the system unreliable. So there are other concepts related to this, such as SLOs and error budgets, which we will talk about in the rest of the slides. So that's basically the core message from this slide related to SRE. So yeah, reliability is minimizing the impact on end users by minimizing outages, right? So so ideally, we should be shipping features, and the end users shouldn't feel anything going on, or they shouldn't see any glitches in the system in terms of errors or latencies or anything, right? So they should see new features coming up, but it should be just seamless. It doesn't break the applications that are running on their systems. So that's what SRE strives to achieve. So what do site reliability engineers do, right? Some of the tasks, typical tasks that SREs do. So this is not an exhaustive list. I'm sure there are others that can be added. But yeah, based on my experience, some of the things that our team does, right? So we define compliance standards and processes, and then we ensure that teams strictly follow these standards and processes, right? So that's extremely important when it comes to running systems. This discipline is extremely important. So you need to define the standards and processes and educate your teams on what these are, and make sure that these standards and processes are followed. And of course, the team writes infrastructure as code, Terraform scripts, Kubernetes Manifest, whatever that's necessary. And all of this code will live in code repos, defining build pipelines, and helping development teams integrate with these pipelines. Another thing is, when we do this kind of definitions, we try to stick with, again, standard ways of doing things. So like our team runs multiple clouds, right? So we have standardized ways in which build pipelines should be defined, what are the stages, so all those things have to be adopted across multiple clouds, right? So like, at least for the organization, it is always good for one organization to have standards that span across all of these different teams, right? So different teams might be running different applications. Like in WSO2 we run Choreo and Asgardio, two different clouds, but the templates and all these things are shared, right? So the teams are have to follow these standards. So the other thing is, setting up monitoring and alerting. So like that plays a major part. So I have a separate section, a few slides actually covering that. That's one of the core areas when it comes to SRE, monitoring and alerting. So we'll go to, when we will discuss more when we go to that section. Backup and recovery, disaster recovery strategies, threat modeling and security scanning. So when you're running systems, you have to anticipate attacks. So like so you need to model the threat, right? Before you put the system online, you have to go through the deployment architecture, and you need to look at what kinds of attacks can take place, and based on that, you need to do some modeling, and then come up with threat mitigation strategies. And of course, you need to do security scanning. Again, this is very easy, or it's very seamless when you have infrastructure as code strategies, and your code is in a code repo. You can integrate security scanning into your CI/CD processes. And then of course, when you're running systems, there are going to be incidents, right? Incidents in the sense, something failing, right? One of a critical component failing, or or some errors, unexpected errors occurring in the system, unexpected latencies, or or actual threats, which you might have DOS attacks coming into the system, which are classified as security incidents. So those are also handled by the SRE teams. Then of course, when you go into like when your SRE process matures, chaos engineering is another aspect that you can adopt. So there actually what you do is you're proactively, you guys would have heard of Chaos Monkey and so on. So there is a tool called KubeMonkey for Kubernetes. So proactively, you try to introduce failures into your system, and you try to see whether your system is resilient, right? So you kill a pod, right? Or you kill a group of pods, take a node down, right? So things like that. You introduce some chaos into the system, and you shake it up a bit, but your system has to be resilient. So chaos engineering is that discipline of proactively trying to break the system, and thereby figuring out the shortcomings and tying up those loose ends. And of course, when there are incidents, you need to do a root cause analysis in depth. So like you are trying to see why this occurred, so that you learn something from that, and then what measures can be taken to avoid it in future. Sorry. So root cause analysis is another very important aspect. And then of course there are like routine tasks that are done by SREs. It's generally called toil, right? So routine things that you need to do on a daily basis or weekly basis, monthly basis. There is some level of stuff that needs to be done sort of manually, right? So that also is still, you can't completely eliminate those things. So those things will also be part and parcel of an SRE's list of items to be done. Another aspect is cost analysis and optimization. So like when you're running these systems, you have to, when your systems are running, you can see the resource usages, for example, right? So if we can look at those aspects and see how we can optimize, either through scaling policies, or it can be changes to your deployment architecture. So based on that, you can make different decisions. So over time, when you have the data, you gather this data, and then there are tools actually that will make recommendations for you. So you can use those tools. For Kubernetes, there is this tool called KubeCost. So you can it will basically show you what resources are idling at what times. So you can adjust your scaling policies accordingly, right? And then, like, of course, if you're running on a particular platform such as Azure, they have their own cost management tooling. So you can use that and look at the recommendations and do optimizations. So that's also another task. So let's just go into some core concepts and methodologies. CI/CD and Git Ops. So CI/CD, like developers are very familiar with this, right? So when it comes to modern software development, everybody uses CI/CD now, right? So it's like build, test, code, and the cycle continues. So how do we apply that for infrastructure and Kubernetes, right? So if you look at so the strategy is, like you fork, right? When we do development, we create a fork from the main repo, then we might create a branch, then you make some changes, then you locally build it, then you send a PR to the original repo, pull request, then there will be pipelines configured, which will do continuous integration, which will do some validations, security scanning, static code analysis, run automated tests, and once those succeed, you can it will be reviewed. You can require reviewing by a person. Once that is succeeded, once that stage is passed, it will be merged, and then the code will get deployed. So the same way of doing release management or CI/CD for software is used when it comes to systems as well, right? So here you can see that code, it goes into Git, you build, and then that results in building an image, right? Container image. So similarly, we have like app infra definition, which is like Terraform scripts and things like that. The underlying or the lowermost layer of your infrastructure, again, that's managed through Git. You use Git Ops tools, so you follow the same process of fork, branch, change, build, PR, and so on. And then finally it is deployed into the relevant cluster, right? So completely automated through Git Ops, right? And of course, for the Kubernetes Manifest, you can do the same thing. So this is exactly the methodology that we are following in WSO2. So we have code repos for the code repos are the repos on which development teams are working. So that's where they develop features. And then the SRE team maintains the infrastructure and app infra repos, and we follow this exact methodology. So like any change to infrastructure comes as a pull request, right? So you send that PR and you run CI, you do the security scanning and all that stuff, and then if everything succeeds, it is deployed into the relevant cluster. And say that particular change, if it results in the cluster being broken, right? So you can now revert, right? You can simply revert that PR and go back to the previous known working state. So that's the beauty of using Git Ops. And then you have a complete trail of what happened, right? Who did what? That history is there, so that you have a complete audit trail of every change that went into your clusters. So another very core concept related to site reliability engineering is around login. So let me go through this example where we have a Kubernetes cluster with a few nodes. There is this. This is like a specific example for Azure. So the WSO2 clouds run on Azure. So we have this OMS agent daemon set, which is running on each node. It is basically gathering information about everything that's running on that particular node. And then there is a deployment OMS agent RS or a replica set that publishes this data to the log analytics workspaces, right? So all the data is published. So this data can include like everything, like your system logs, your application logs, events, Kubernetes events, other information related to pods and whatever that is running on your system, information related to the nodes. All of these things get published into the log analytics workspace. And then there is the data explorer through which you can now query and visualize, and you can filter out these logs. So these are some of the some example queries. So like so once we have in the previous step, right, we publish all this information, it goes to a central workspace, and now you can run queries, right? So you can run queries to actually get information. So you can get what information about the container inventory, the images, and blah blah blah, their started time, finish time, and so on, whatever the events that took place. And then another important thing is related to performance. So in the third example, we have CPU usage. So like certain that there are like we have come across scenarios where certain containers start consuming very high CPU, right? CPU usage due to, it can be due to various issues, right? So we can detect those things. Some containers might consume very high memory, and because of that get OOM killed, right? So out of memory killed. So all of these things you can now analyze, right? Of course, Kubernetes will take measures to automatically OOM kill and spawn another pod in that place and so on. But the thing is, like, if that continues to happen, it indicates some issues. So once we analyze this information, we can now take certain measures, right? So this is sort of a simple workflow. So you publish the logs and then you run the analytics like the queries that I showed you earlier. And then you can actually detect any anomalies, right? For example, if you see that in a particular deployment, some pods are always consuming very high memory, or high CPU or something like that, right? So in that case, you can take several measures. You can maybe externally try to terminate that or something, especially if it's going into high CPU. What happens is Kubernetes doesn't kill that pod, it throttles it. So that can result in users seeing very high latency, but the system continues to run, but it's not a good experience. So it's as from a systems point of view, we might see that as a failure. So what we can do is, when we detect such anomalies, we can alert. So you can alert using a separate system. In our case, we are using service now. So you send alerts, and then you have an incident management process. So like alerts can have like different severities, right? So alerts can be severe, and it can be less severe, or just warnings, right? So based on that, the response would change, right? So we have the incident management process. So I have a few slides on incident management, so we'll get to that. So a few words about observability and monitoring, which is extremely critical when you're running cloud native applications. So there is a difference between observability and monitoring. So like most people sort of use it synonymously, but there is a difference. So like you have to make your system observable. So if you look at this pyramid here, right, you have to make your application or your system code observable in order for it to be monitorable, right? So if you don't have the observability enabled, or if those probes or instrumentation is not there, if your code is not observable, you won't be able to monitor that. So again, this is very critical. So this is what allows us to analyze and find out whether the system is behaving in a proper manner, right? So when it comes to monitoring, there are two levels, right? So we have system level as well as application level. So if you look at system level, it's all about about the cluster, the pod, node, system level services. If whether the Kubernetes API server is running, right? Whether system logs are working, is there any intrusion into the system, is there a DOS attack coming in? So all of these things are sort of peripheral or non-functional stuff that are related to your system. So that is extremely important. In addition, there are things that you have to do at application level. So this is basically like when I say application, this is your business application. So So there can be things like all your system level monitoring might indicate very good health, but at the application level, due to certain issues, you might have internal thread pools which handle requests, right? Those thread pools may get exhausted, right? So if so what can happen is users will now start experiencing either errors, or they would get timeouts and things like that, right? So you need to have the probes in your application to monitor those things. So like developers also have a role to play in actually enabling observability for their applications. So they need to enable these probes, and once those probes are there, now we can bring in the rest of the machinery to enable monitoring and alerting, right? So like a very critical aspect is, like logs, right? You might within a particular time period, if your application is emitting lots of error logs, that might indicate some kind of problem in the application. So so we using the analytics, we can sort of catch that particular scenario and send an alert out saying, okay, this application seems to be in a broken state, because within the last 5-minute window we got 100 error logs, which is not normal. So then the relevant people will be alerted, and they would take the necessary remediating actions. Right, so I have a few slides on incident management. I don't want to go through all the details, but we'll just get to the idea behind this. So like when it comes to incidents on the cloud, there is this thing called the impact and the urgency. So you always look at those two aspects, and based on that you decide what the priority of that particular incident is. For example, you can see we have a high impact, high urgency issue, so that will be a critical issue, right? So but there could be a low urgency, high impact issue, which is categorized as a moderate level incident, right? So this multiplication, or this product between these two factors, will decide the priority you need to give for these particular incidents. So like your system, remember that diagram, right? Your system emits these events, and then you have the alerts, and then you know that this particular alert, if this particular dB is down, we know that the impact is high and the urgency is high. It has to be fixed fast, because now your users are starting to see errors, right? So that's the impact urgency matrix. And then this is the incident management process we have defined in WSO2, which is used by the SRE team. So like incidents can come through different channels, right? So on this on the left we have all the channels. So users may report a particular issue, and then what happens is we have a system which creates a case, and then when you analyze that case, you might figure out this is actually due to something failing in the system, right? So ideally this shouldn't happen. Before users see an anomaly or a problem in your system, the machinery that you have built into should proactively detect these things. But it can be a case where you have due to oversight, your system didn't detect an issue, but a user detected it. Then a case gets created, and that leads to an incident. Similarly, there can be other team members, while doing some testing, they might find incidents. So these are all like humans. And there can be alerts coming in through from different channels. So these are like your systems are monitoring the deployment, and then it sees that there's some problem, and then it creates an incident ticket. So again, this is in service now, and then what happens is the teams will now take over. So what will happen is, depending on whether this is a major incident or a minor incident, either the team will get an email, or they would get a pager duty alert or something like that. But they will get a phone call, right? So depending on that, they might, if it's a major incident, they would get woken up in the middle of the night, and they would have to deal with this. And then there is a separate flow for that. So similarly, there is a special casing of security incidents, because security is another specialization. So we have a separate specialist team that handles that, the security operations center team, or the SOC team. So security incident flow is very similar, but we treat it as a separate thing, because security incidents have to be treated in a more critical manner. So again, I don't want to go through the details of the normal incident management process. So typically what happens is, I just want to talk about runbooks. So SRE, one of the tasks that SRE does is create runbooks. So there can be certain alerts. You know that this, you have seen this in the past, or you anticipate this. So in case this happens, there is a particular runbook. You take that runbook, you execute these steps. So what happens is, an incident will come, will take place. Somebody gets paged. They might have to wake up in the middle of the night. Then they simply look up these runbooks. So runbooks have to be very simple. So step-by-step instructions on how to restore the system. So we are not trying to fix the underlying root cause, right? So that's the very most important thing here. We are not trying to fix anything. We are trying to bring back the system to a known correct working state. So the runbook basically aids in that. So once you do these steps, so it can be something as simple as restart this pod, or or kill this particular pod, something like that. So it will have some simple steps like that. So you initially follow those steps and resolve the issue, and then of course once that is the issue is resolved, you have to go to a post-mortem stage and try to figure out why it occurred, and what actions could be taken to sort of remediate that. So what can happen is, even after a runbook entry is executed, your system may not come back to the proper state. So in that case, there is another level of escalation where a separate team with more expertise comes in, with more in-depth knowledge or product knowledge. So it can be due to a recent feature that got shipped, which is affecting something else. So then you need to bring in people with in-depth product knowledge. So you get into that situation, try to resolve it, and then what can happen is, still you might not resolve it. So you start a war room, and this focus team tries to restore the system within a specified time period, right? So so that's basically a very summarized view of how you handle the incidents. And again, major incidents are categorized separately. When a major incident is declared, first we try to see whether that is a disaster situation, right? So is it because a complete region has failed? Okay, so something like that. So in that case, there is a separate process to initiate disaster recovery. So another important concept is related to SRE is SLA, SLO, and SLI. So SLA, so let's start with that, right? Most people are familiar with that, right? So an SLA is a contractual agreement that you have with your users or your customers. So if SLAs are violated, there can be significant consequences, right? So which are often financial in nature. You might have to you might have to bear some financial consequences. You might have to it might even go to courts, right? If the SLAs are violated, then your customer loses significant revenue. So we typically, SLAs, we don't give 100% SLAs, because you can't ever give 100% SLA for any practical system. So it's given in terms of number of nines, right? 99.9949, or 3.5 nines, 99.95, right? Something like that, right? So based on that, we have something called SLOs, service level objectives. So this is an internal measure. So SLIs and SLOs are internal measures, SLAs are external measures, right? So with SLOs, what we are trying to do is we are trying to set targets for ourselves. So let's say for a particular service foo, sorry, we have a 99.9% SLA, right? 39 SLA. But for the, we try to keep the SLO a bit more sort of stricter, right? So we go for probably 49 SLO, which is an internal target. So that we have a bit of a buffer to play with, right? So your SLO, you always target something higher, but you promise lower to your external parties. So this is what we try to adhere to, right? So like SLOs are based on something like we typically define it for what we call user journeys, right? So depending on your application, there can be different user experiences, right? In Choreo, we have the code editing experience, then we have the code deployment experience. So those are two different user journeys. So we will give two different SLAs and SLOs for that, right? Because like your code editing might be have experiencing certain issues, but your deployment is now working perfectly fine, right? So those are two different user journeys with different SLOs. So how do you
We have some question from the audience.
okay, you want me to take it now or wait till then?
Uh, let's take the ISLO and not close to the pro.
Yeah,
Yeah,
it
you
is
can answer that now.
close to no, it's not a recovery point objective. So SLO is like RPO, I suppose it's a recovery point objective, right? Related to disaster recovery. So it's SLO is more related to or close to SLA than recovery point objective, right? So RPO means like how much of data you can afford to lose, right? So you, let's say, in a disaster scenario, you might lose 15 minutes of data and you say that's acceptable. So not exactly related to SLO. Yeah, I'll continue. So in order to see whether you're meeting these SLOs and SLAs, you need to measure certain things, right? So you need to measure the latencies, error rates, and things like that, availability. So these metrics are known as service level indicators, right? So these are the indicators. In order to arrive at your current SLO, SLO is basically your target. To basically compare where you are, you need service level indicators. So if that will basically indicate whether you are going to violate the SLO. So which is something that generally is not acceptable. And then there is something called error budget. So like, why don't we go for 100% SLO and 100% SLA, right? So if you try to do that, what happens is you have less room for innovation. So like I said, once you get your system to a reliably working situation, now you can't make any change. You don't have room for error if you go for 100%, right? Because definitely, there are, when you make changes to a running system, it could introduce errors. So you need to have a little bit of room to play with. So that's what we call the error budget, right? So error budget, in effect, if you give it as a formula, it's 1 minus service level of objective. So if you have let's say 99.9% SLO, your error budget will be 0.01, right, for that particular user journey. So that means now you have you're not over promising, so you have some space to play with. So it's the acceptable level of unreliability for a service before it falls out of compliance. with an SLO. So, so this is also a measure of risk you can take in order to get new features in. Sometimes you have to stop services for maintenance. Then they have to, you might want to do routine improvements. Then there can be unforeseen circumstances which are definitely going to happen. There can be network and infrastructure outages. So in order to cater to these things, you need to have this particular error budget, and then you need to actually constantly keep observing that, because you don't want to run out of error budget. So what can happen is, your development team might start shipping features very fast, but since they are, let's say, it's not tested properly, it introduces errors into your system. So at a point, when you have close to exhausting your error budget, so your error budget is also defined for a particular time period, right? So let's say now you are almost close to exhausting your error budget, you can no longer afford to ship any new features. So as the SRE, we will come and say, okay, we are not going to ship new features until all of the current issues are fixed and the system is back to stable. So only after that, developers can come and start shipping new features. So it's again it's a balancing act here. So toil and toil budget. So toil is generally, toil, it's the routine, boring tasks, right? So manual, repetitive tasks. So the thing is, like, we try to reduce this as much as possible. So they say that an SRE's job is, trying to automate him or herself out of a job. So you're constantly trying to, automate yourself so that, you can be made redundant, right? So, but in effect, what you are trying to do is trying to concentrate on adding more value in places where human intelligence is needed, right? But the thing is, like, there is something called toil budget as well. So we don't want to, spend long hours automating something that you run, let's say, once a year, right? So once a year, or maybe even once a month. So because that the code that you write might have to be changed, because there is always an overhead, right? When you automate stuff, you have to write scripts and code and all that stuff, and you need to maintain that as well. So rather than doing that for certain tasks, it might be perfectly fine if you do it manually, right? So you execute a number of manual steps and you get the results. Maybe you have to generate a monthly expense report or something like that, right? You simply do that manually. So that's acceptable. What is not acceptable is, once you start exhausting this toil budget. So like if you measure all the work done by your team, and then let's say your toil budget is 50%. Now, if your team starts spending more than 50% of the time doing these routine manual tasks, then you have to you're exhausting, or you're going over budget, right? So that point you need to step in and say, no, we are going to automate these things so that we are within toil budget. So like a very simple way of doing that is through cron jobs. So here it's a expense report cron job, a Kubernetes job, which runs every month, right? So you give the schedule there, and then you give the repo. You can give a command or image or whatever, so that can Kubernetes. You can have Kubernetes cron jobs that will do this for you. And then, of course, cost management. So you can have like different tools. So for platform level stuff, we have like different dashboards, and you can set budgets and then send out email alerts if you're going over budget and things like that. And then KubeCost is a relatively new tool on the block, which will show how you can optimize costs on your Kubernetes clusters and so on. So cost management is another very important aspect in SRE. Anti-fragility, right? So that is making sure that your system is resilient. So like we have the Kubernetes liveness readiness probes, which provide one level of anti-fragility. And then of course there are tools like Chaos Monkey. Then for like on Kubernetes they have Kube Monkey, which will ensure that your system is resilient. It will give you an idea of how fragile your system is, so anti-fragile. And then of course like I think I have I'm running a bit out of time. I'll try to wrap up fast. Yeah, security. So like this is another very important aspect where you do threat modeling using the SREs methodology, right? Basically like you model the system and then you do a threat. You look at the deployment architecture, you model the threats and you try to minimize it. And because we are using CI/CD approaches, we can integrate tools such as Chekhov, which will scan your Kubernetes scripts and other infrastructure as code to identify vulnerabilities. And then like I mentioned, security is a specialist area, so we have specialists playing that role, and a special separate team, generally with a sub-specialization within SRE called Security Operations Center, which runs the security aspects of it. And then like when it comes to Kubernetes, there are like best practices that have to be enforced, like network policies, service accounts, role bindings, going with the principle of least privilege, and then things like enforcing MTLS between when it comes to communications between um, um, pods or containers in your system. You can do that via service measures. So all these security measures have to be put in place. Yeah, so BCP and disaster recovery is another aspect of it. So what we are trying to do here is creating a system of prevention and recovery from for potential threats to the entire company. So like ideally it is for all functions of a company. So SRE plays a major role in actually helping with defining that aspect. But just because your infrastructure is running and there is another, let's say, critical function in your company that fails, that could be a major threat to your business, even though the infrastructure is running. Okay, I think I have a couple of more slides and we can wrap up. So that there are different ways in which you can sort of structure. So this is one model in which we have structured our teams in WSO2. So we have the SRE discipline or the co-SRE team, which works across multiple cloud teams. So the whole point here is, the knowledge and the standards and all these things are, shared and enforced across multiple teams. And an important aspect here is the platform engineering team. So this is a glue team between the developers and SRE, right? So they make sure that the CI/CD pipelines for component development. So this is actual business code, right? So component teams are writing business code which are going to run on cloud systems. So the platform engineering team makes sure that the proper CI/CD processes are followed, the repo structures are adhered to, and so on, right? So they are sort of specialists who liaise between SRE and the business team. So this is a model that is working for us, and this is a model some other companies have adopted as well. Yeah, so some final thoughts on how you can adopt SRE for your company. So like it might sorry, it might sound a bit overwhelming. So like I mentioned, when you're going to run stuff, cloud native applications, it looks very simple, but in effect there is a major back office function going on to keep these things running and alive, and making sure that your customers are happy, right? So the SRE function in WSO2 actually, we started it in 2020, started small and evolved. So, you don't have to get overwhelmed. You start small and evolve. And typically, companies have their own existing team structures and processes. You can't change them on day one completely. So look at existing team structures and processes and see how you can adopt it. So this is what happened in WSO2 as well. We already had our customer success and managed services teams and so on. So we basically didn't make any major changes with those structures. We adopted SRE while preserving most of those structures. And another major challenge that we found was it's hard to recruit experienced SREs. But the things like I mentioned, it's very natural. These are very natural field for software developers. So you can have a program where you get developers on board, and then you train them on the job to become SREs, right? And then of course, certifications are really important, because like most of these certifications are very practically oriented ones, like the Kubernetes certifications, cloud platform certifications. And there are programs like Well Architected, where you work with specialist on Azure platform or AWS or whatever. They will review your architecture and basically tell you how best you can architect your solution for that particular platform. Then actually maintaining a central knowledge base and documenting everything, so that your team can quickly, new people can come on board, and your team is always aware of what needs to be done on the conventions, best practices, and so on. So those are like important aspects. And then you can keep on continuously improving your processes. And of course, work closely with development teams and engage with all stakeholders. Finally, when you get to a certain level of maturity, you can think about different certifications and reports and stuff, things like that. This will actually give your customers confidence about your systems. So as you can see, you can start small, and then you can gradually evolve, right? So finally, key takeaways are even though Kubernetes and app development and cloud native aspects, these are just the tip of the iceberg in your organization's overall SRE and cloud native story, right? So just running it on the cloud or running Kubernetes doesn't solve everything for you. So there's a lot going behind the scenes. So establishment of an SRE discipline is essential for running seamless operations. So start small, adapt, and evolve. So that's the summary. And yeah, do we have questions? Sorry, I think I'm a bit over time. Okay, must SRE be good at code? If you are good at code, I would say it's an added advantage. But if you can think like a programmer, I think that is what's important. Like not any specific language per se. What is important is thinking like a programmer. Modularity, reusability, coding practices, right? So of course, if you are going to write on Kubernetes, if you are trying to write CRDs, custom resource definitions, and things like that, you might need to do a little bit of programming, typically in Go. But I wouldn't say that any a specialization in any specific programming language is essential. But yeah, it would definitely be an advantage. Yeah, for sysadmin, from sysadmin, can someone get into a SRE role? Yes, of course. On our team also, we have people who have come from sysadmin backgrounds. Again, that also the systems. There's an echo. Yeah, the systems experience also will help. So I don't see that being an obstacle. It's definitely, I think, even I think some of the guys, I think, I think Kanchana is from the systems background. So so it's not definitely, I would say that is also an advantage.
Okay, so next one is any guideline when planning for redundancy on Kubernetes?
Yeah, redundancy on Kubernetes in the sense, I'm wondering whether it's like related to high availability and things like that. Yeah, definitely. You need to, yeah, applicable. You need to run HPA, horizontal pod auto scaling. So like to allow, I think. Uh, your system to operate properly when there is load and things like that. Having a minimum of 2 replicas, those things are essential. So the other thing is, again, it can even, I think, relate to backups and recovery, right? So when it comes to your system, so this is not actually Kubernetes specific. When you're running any system, you need to have your backups, and then you might have a, if like run if you're on a cloud provider, you might run 2 different zones. One might be sort of a backup zone, and then in case the primary zone goes down, you have your backup zone to take over. So then you need to do some, might have to do some data synchronization between zones. Eventually your data might get synced into that particular zone. So there are like different aspects. So like those are some of the things that come into my mind.
Okay, let's move to the next question. Nilesh is asking slide deck.
Yeah, definitely. Yeah, I'll slide the slide deck. I'll send it over to Chamod. Then
Yeah, I will share with the community.
yeah.
So yeah, now it's time to ask question from the audience and give facts. Aziz, can you ask 3 questions about today's session? And the people who answered each question correctly will get one of these pack from WSO2.
Okay.
So
You didn't tell
you
me
have to
that in
ask 3 questions.
advance. Okay. Let me think about it. Okay. So what is the name of the Kubernetes tool that I mentioned, which can be used for cost analysis on Kubernetes clusters? So this is
That's too
something that
easy.
it's okay. I'm just trying to see whether people were paying attention. Is that counting as a question or not?
Yeah, yeah.
Right. The other thing is, okay, what is the difference between observability and monitoring? Okay, one more, is it?
Yeah.
So let's ask. Okay, what is Git Ops? Okay, can I see the comments here?
We have 3 gift packs. So answer one of them, one of a question, and you can get the sack pack.
So what's next, Jamod? Like I have to pick the answers or like?
Yeah, you have to pick the answers.
Okay, so yeah, first one was easy, like you said, kube cost. So somebody mentioned kube monkey, that is for actually chaos engineering.
So the winner is Tenuka Lawrence, right?
Yeah, he's the first one to answer, right?
Yeah.
Then the second question was the difference between observability and monitoring. Who has answered that? Nilesh has answered. Monitoring is a subset of observability. Monitoring, yeah, not really. I wouldn't say that's okay, but observability is a general concept about making your system observable, right? So once your system is observable, you can monitor it, right? So if your system is not observable, you can't monitor it. So that is it. So you see, if your system is more observable, you can put in more probes and monitor it better, right? So that's the whole idea there. So like, of course, your system can be a black box. You don't have anything about it, then you can look at it from outside, right? So like you only have external observability in such a case. So you can look at the black box and say, okay, there is a crack in this box. If there's something leaking, you can say, okay, there's a liquid leak inside this box and it's leaking. But then if you have some sensors inside that box, right, you know exactly what has happened. Either the pressure has increased, right? So now let's say the pressure has increased inside that box, and then due to that, your system, it's basically exploding, right? It's cracking, right? So by putting that pressure sensor, you have made your system observable. So from that sensor, you can get an output and now monitor that. So that is the sort of example. But yeah, has
Someone
anybody?
has answered, right?
Yeah. Uh, so then Git Ops. Yeah, I think I asked about what Git Ops is. Yeah, so Git Ops is basically applying Git. Like software engineering practices, there are so many practices that we apply, but this is specifically to code repository management, right? So applying Git concepts to your infrastructure as code. So that is basically what Git Ops is. I think the closest answer here, I think the closest answer is I don't say like Buddhita answer, right?
This one.
Yeah. Okay.
Okay. Shall we ask another question or wrap it up?
I don't know. I am 20 minutes over time, I think.
Yeah, of course.
Hopefully people enjoyed the session and it was informative, and hopefully everybody learned
Yeah.
something.
So let's wrap it up. And thank you very much, Azeez, and thank you for everyone who attend to today's Kubernetes Sri Lanka meetup. Stay safe. See you next time.
Thank you, guys.